Welcome to lesson 4.3, working with formulas. I don't often read out what we're going to do, but today we're going to work on two things: identifying the number of terms on each side of an equation, and then secondly will be to isolate a desired variable in a formula by reversing the order of operations. That's going to be this Sam Deb again. So we're going to practice a little bit just using the perimeter formula. We know that the perimeter equals 2 times the length plus width. This is for a rectangle. You probably figured that one out. So if this is my length and this is my width, that highlighted in yellow would be the formula for it. Question A says, find the perimeter if the length is 9 meters and the width is 6 meters. So we're pretty good at that. Wherever there was an L, so 2 bracket, wherever there was an L, I'm going to write a 9. And then wherever there was a W, I substitute in the 6. So I get 2 times 15, which is 30. So I get that the perimeter is 30 meters. Really important to make sure you do units when there are units in a question. Part B says find W, or the width, if this time we know the perimeter is 60 and the length is 16. So if we do straight substitution, we would get 60 equals 2 times the length is 16 plus W. Now there's two ways we can do it. I'm going to show both. The first way would be to undo that dividing, because division up here, division comes before brackets. So we could, in this way, divide both sides by 2, and we would get 30 equals 16 plus W. Bring the 16 to the other side, so 30 minus 14 equals W, or 16, I again jumped ahead. Bring the 16 to the other side, it becomes subtracting 16, which would give us an answer of the width is 14 meters. So that's one way of doing it. The other way of doing it would be if you have 60 equals 2 times 16 plus W, we can distribute. We can distribute the 2 onto the brackets, and we would get 60 equals 32 plus 2W. Bring the 32 over to the other side, so 60 minus 32. I'm going to zoom in on this. I should have done that earlier. 32 equals 2W. So that gives me 28 equals 2W. We want W by itself. Divide both sides by 2. And we get, again, that W equals 14 meters. So both ways are going to work. But this way 1, this is the one we're going to focus on, because we're not always going to be able to solve things by distributing. The third one wants us to find the length if the perimeter was 84.2 and the width was 5.4. So I'm going to sub in again. 84.2 equals 2 bracket. Length, we don't know, plus the width, 5.4. So I'm going to use method 1. First thing I'm going to do is divide both sides by 2. So that gives me 42.1 equals length plus 5.4. I'm going to bring the adding 5.4 to the other side where it turns to subtracting. So 42.1 minus 5.4 equals the length. And 42.1 minus 5.4 gives me 36.7. And not forgetting the units are meters. So that should be a refresher from grade 8 math. We're going to move on to other types of formulas. And a formula is an equation that contains variables. So here's a new word, a new piece of terminology or vocabulary. A formula contains variables. And sometimes you're going to need to solve for or isolate a particular variable. So we're going to have 4 steps. Step 1, check which variable we're isolating. Remember, isolate means we're getting it by itself. Getting it by itself. Step 2, isolate the variable by reversing the order of operations. This part, reversing the order of operations, this is Sam Deb. Make sure the variable is on one side of the equal sign and everything else is on the other. That was supposed to be highlighting. Make sure the variable is on one side of the equal sign and everything else is on the other. Then we will simplify, and if we're given values, we'll substitute them in. So just a quick reminder, what is a term? A term is when we have a coefficient out front, sometimes it might be an invisible one, and it's multiplied by a variable or some variables. So all of those together make up a term, and then multiple terms are going to be separated. So if that was a term, I could have other terms that are going to be separated by pluses and minuses. So each one of those boxes would be a term separated by a plus and a minus. So in the formula, E equals mc squared, if I have a term on each side, I want to isolate m. That means I want to get m by itself. If I look at this, I'm like, okay, what's happening to the m? Well, it's being multiplied by c squared. And we undo multiplying by dividing. So I'm going to divide both sides by c squared, and we'll get that m equals e over c squared. So a little flow chart, guideline to isolating variables. Look at the side with the desired variable, determine how many terms are on that side. And if there is one term, so if there's only one term, we're going to use multiplication or division as appropriate to get it by itself. But if there's two or more terms, the first thing we're going to do is reduce that side to one term by using addition or subtraction, and I'll show you what that means. So we have S equals A plus B plus C divided by 2D. And first they would like us to isolate for D. So A, I'm going to call that, no, I don't want to use A's because we have all these letters. 1 is going to be isolate for D, and then 2 is going to be isolate for B. Okay. So when we look at S equals A plus B plus C, the first thing I notice is that D is on the bottom. And whenever we want something isolated, it's not going to be on the bottom of a fraction. It's going to be up top. So there's a lot of different ways we can do this. We could multiply both sides by 2D. We could flip both sides upside down. So I'm going to show both ways. So I guess Roman numeral I and then II. So the first one is going to be multiply by 2D, and the second one is going to be flip both sides. So if we multiply both sides by 2D, watch what happens. I get S times 2D equals A plus B plus C all over 2D, and then this whole thing is multiplied by 2D. As we learned in the last lesson, when we have the same thing up top and down below, we can cancel them. So cancel, cancel. And on this side, on the left side, I'd be left with 2SD equals. And then on the right side, I'm just left with A plus B plus C. I want D by itself. So isolating for D. To get D by itself, D is being multiplied by 2S. So we undo multiplying. I would divide this one by 2S. And I'm going to divide this all three of these terms by 2S. And I would get D equals A plus B plus C over 2S. So that's one way of doing it. The other way of doing it would be to flip both sides, and by flip I mean turn them both upside down. So if I were to flip them, I would get, this S was really S over 1 up here that I just highlighted yellow. So if I flip it, I get 1 over S equals, then I'd have 2d up top and a plus b plus c on the bottom. Even though it's not showing, I hope you remember that that means there's really a ghosty bracket around that denominator. It has to stay all together. So there's two things happening to d. If we look at d, d is being multiplied by 2, and it's being divided by a plus b plus c. So if I want to get rid of that timesing by 2, when that multiplying by 2 goes to the other side, it's going to turn into dividing by 2. So it would move down here. This timesing by 2 turns into a the timesing by 2 turns into a dividing by 2, which means it goes on the bottom. D stays up top, a plus b plus c. And now if I want to get rid of dividing, when it goes to the other side, dividing on the one side would turn into a plus b plus c times 1, which is just a plus b plus c, over 2s. So I know this really seems complicated, and you're not getting a number at the end, and that can be frustrating. But that's sort of about, well, it can get a little harder if we have to take a square root or a square, but that's about as tricky as it gets. Question 2 is actually a little bit easier. If we want to isolate for b, we want to get b by itself. I'm going to rewrite it and then zoom in. S equals a plus b plus c all over 2d. If we want to get b by itself, we're going to do reverse BEDMAS or SAM-DEB, remembering that there's like ghosty brackets around the a plus b plus c. So brackets are going to be the last thing that we do. Before that, we're going to get rid of the division. And when division changes sides, it turns into multiplying. So I'd have s times 2d equals a plus b plus c. So that's 2sd equals a plus b plus c. I still want b by itself, and it's being added, the a and the c. So I'm going to have these guys change sides, and when they do, addition turns into subtraction. So we get 2sd minus a minus c equals b, and that would be that answer. So I don't know about you, but I find that a little bit easier than, the box isn't working. Forget the box. Or leave it there. Okay, let's do some more. Question 2a wants us to solve for x. And this is actually a really straightforward one, because right now all that's happening to x is there are 3 terms here. Remember, terms are separated by adding or subtracting. So 1, 2, 3 terms. First thing I'm going to do is I'm going to get rid of the terms that don't have x's in them and move them to the opposite side. So x stays where it is. On the right side, we had c minus y. I'm going to bring the a to the other side. So adding a turns into subtracting a. And then subtracting b, bring it to the other side, is going to turn into adding b. And that's it. Question B. It didn't show up for me, so maybe we'll figure that out later. Question 3D. D equals ut plus half at squared. First, it wants us to isolate for u. So 1, isolate for u. And then the second one's going to be isolate for a. I'm just doing that so that I remember and don't get distracted and forget to do the second one. So if we're going to isolate for u, we look and see how many terms do we have, because we're isolating for u. Isolating for u. U is in the first term, and then we have that second term. So the very first, I'm going to rewrite it, because the very first thing we're going to do is take that second term that was being added on the right side. We're going to move it to the other side where it turns into subtracting. So it'll be d minus half at squared equals ut. Then I'm going to go on and undo the multiplying. So to undo multiplying, we're going to, if I'm dividing ut, I want u by itself. So I'm going to divide this term by t, that means I'm going to have to divide every single term by t. And our final answer here would be d over t minus, up top we have 1, we don't need to write that, a, t squared up top, t down below, leaves me with just 1t. The denominator will have a 2. And we did all of this because we want the t's to cancel so that we have u by itself. Isolating for a. So d equals ut plus half a t squared. So this time, if we're isolating for a, there is another term, this ut, and we're going to bring this term over to the left side. So d minus ut equals 1/2 a t squared. The 1/2 might look a little bit tricky, but we can get rid of it with our trick with fractions. Our LCD would be 2, so we're going to multiply every single thing by 2. I'm going to use red for this. And if I do that, watch. If I take 2, multiply it by everything there, or I could straight up just write a 2 here and a 2 here, and this whole term here times 2 as well. On the right side they cancel, and on the left side I'd have 2d minus 2ut equals at squared. I want a by itself. A is being multiplied by t squared, so we're going to divide every single term by t squared. We'll see if we can do any canceling. Here we're going to be able to do some simplifying with the t squareds, but the first term stays that same, 2d over t squared minus 2u, 1t up top, 2 t's in the denominator. I'm left with just 1t in the denominator equals a. Okay, I know that these look complicated. We're going to do one last one together, and then we'll do more in class. So, 2 things here. 1, isolate for little a. And I know it's so annoying. Why have a big A and a little a? Aren't they the same thing? No, they're not. In some science or even in some math, like right here, this is the formula for the area of a trapezoid. They use the same letters and just differentiate by making them capital or lowercase. So this one, first we're going to isolate for a. I'm going to rewrite the equation. A equals half h a plus b. I want to get a by itself. We got this fraction in there. So the first thing I'm going to do is get rid of it by multiplying everything by the lowest common denominator, which would be 2. So it cancels out that fraction, and I'm left with 2a equals h bracket a plus b. So if I'm going SAMDEB to solve for this, I need to get rid of brackets last. So I'm going to, right now this bracket is being multiplied by h, so I'm going to undo that by dividing both sides by h. So I get 2a over h equals a plus b. I still want a by itself. We have plus b on this side. It's going to move to the other side and turn into subtracting. So 2a over h subtract b equals a. And that's the first one isolated. For the second one, I'm going to write it out again. A equals 1/2 h a plus b. Then we'll zoom in here. We want h by itself. But it's still the same fraction, problem, issue, whatever. So we're going to multiply everything by 2, each of the terms by 2, so that they cancel out, and we get 2a equals h a plus b. Now we're trying to get h by itself. H right now is being multiplied by that bracket. So the way to get h by itself, we're going to divide both sides by that bracket. And when we do that, The a plus b's in the bracket cancel, and we're left with 2a over a plus b equals h. And you might be thinking, oh my God, why would I ever want to do this? Where would I use this? If you have ever done any computer programming or any sort of science lab or stuff in spreadsheets, if you were doing some sort of strange experiment on trapezoids and you wanted to have your spreadsheet or your computer program solve for h, you would have to tell the computer program exactly what had to be calculated in order to get h by itself, because it can't do the backwards thinking so well on its own. So there actually is use for this in terms of spreadsheets and programming. Thanks so much for watching.